Hi, I'm Dr. M. Kamakshaya, open source software evangelist, enterprise solution architect, and academic of data science and analytics. So, for the past few videos, I've been demonstrating how to perform numerical calculations, data analysis using Hadoop MapReduce Streaming and Python programming. In my previous video, I've explained how to calculate a Carl Pearson coefficient R, right? So, in this video, I'm going to show you how to calculate uh, constant and coefficient for simple linear regression. Okay, we simply call it as a comma b or alpha comma beta or something, or beta not beta. There are so many notations in statistics. So in simple words, it is nothing but a constant and a slope. So how are we going to do that? I have quite a few. So if you go online and search for the formulas, and you will get umpteen number of formulas, each one by. I want to use something this one. So because I have tested with sample data sets, and this is correct in X. I mean, I have carried on with a few calculations when I did these calculations in MS Excel or any other spreadsheet. In spreadsheet application, this formula worked for me for slope. This is a formula for the slope. B1 is the slope and B0 is constant. So we can calculate the slope by using Carl Pearson coefficient R, with Sy denotes standard deviation of R and Sx denotes standard deviation of X. Okay, now there are a couple of other formulas. Don't do, because you will end up with errors. So this one, for instance, I already experimented with these formulas, and there are values. I'm able to calculate the values but end up with wrong results. So my strategy for this video is that I'm going to calculate the slope by using this formula, because I already have a function for Carl Pearson coefficient R, and then I already shown you how to calculate the standard deviations in one of my videos. Now, using all those functions, I will show you how to calculate the coefficient and whatever the constant. Constant is simply nothing but y bar minus the slope multiplied by x bar. So that is what is going to be. Now, without talking much, I don't know why I opened this. Okay, fine. So without much discussion, let us straight away jump into the action. So here, I think I have Hadoop version 3.3.1 and Python. I do a lot of mistakes. Okay, see, like that. Python, you have to bear with me. Python 3 version. Okay, now my cluster is not on. Start or -sh. And meanwhile, I'll take you to some other. Why did I open this? Okay, okay, already opened. So I'll close this first, and then. So now I'm in a particular directory called Python MapReduce, which I have created in one of my previous videos. You can just go back, and I have scripts here. What is my data? I have data. This is just a data which I used in my previous video demonstration, and now mapper function I use get it, which gedit mapper. It is a simple logic that I'm just dividing the line into different elements, and I am trying to pass required elements from each line into certain variables defined as x and y, and finally I'm printing x and y to the console. Now, what is reducer? So this is what is very critical. So I'm going to show you gedit. Actually, logic, most of the logic happens in reducer, right? So that is what is our learning from the past few videos. So in my previous video, I have shown you how to write a function for mean. So if you don't know all these things, just go back to one of my videos and watch how to calculate the arithmetic mean, standard deviation, variance, etc., etc., etc. So this is function for mean, this is function for variance, this is function for standard deviation. Okay, already explained all these things in one of my videos. Now I have some product, sum of squares and some square. Why I need all these functions? In my previous video, just before this video, the video just before this video, I've explained how to calculate the Carl Pearson coefficient R, and I require all these. I need all these functions in order to calculate the coefficient R. Now I need to write code for slope. So I call it as slope x comma y. We need to now. So what is the slope? This is just going to be curl of x comma y. So that is what is the formula, right? I have shown you. So this is the curl r coefficient r times the ratio of standard deviation of y divided by standard deviation of x times. So this is the ratio std of y divided by std of x. That's it, I think. Now we return out. And how are we going to calculate the alpha? I mean constant. I call constant x comma y. Do we leave x comma y? Let's take it. And now out is equal to the mean of y minus slope x comma y times mean of x. That's it. So now we need to, I have to return this constant, return out. So that's all. So these are the two additions to my earlier script, the script which I used in my earlier video. Now it's time to test. So I'll just come down, print with constant x comma y, and then slope x comma y. So say all the best, and then so close this. Now I'm going to, I also close this browser, I don't need it. Now cat data python mapper, and then python reducer. Yeah, I'm getting this is actually the alpha, and then this is beta or a comma b. This is constant, and this is the slope. So okay, so I've carried on this. I calculated these measures in my local file system, and now it is time to do it in the cluster. So that is actually the major objective of. So I have my data node and name node. Yes, very good. Now Hadoop job. So one folder back, and then I'm going to a folder where I have this Hadoop streaming job. Okay, now file is I will take the total path Python MapReduce, and then mapper, and then mapper is of course same. So I'll just do it. Okay, I can copy this, control shift V, and then file again. This time it is reducer, and then reducer, again reducer, and now import. I think I already have this in my HDFS. It is data.txt, I guess. Now output, hold on a second. So this Hadoop fs ls. Do I have a folder with name output? Then I need, yeah, I have. So Hadoop fs rn or output. Okay. So now let me go back, and then so my output is going to be output folder is output. So that's it. So Hadoop jar streaming jar file mapper reducer and input output. Yeah, of course. Come on. So let's wait for the MapReduce streaming. Now the job has been submitted with certain ID to the cluster. The parallel processing has been started. The job is running now. The ID is 000 underscore 0001, something which is, so this one I'm talking about, the job which is submitted to the now in as action, yawn in action, YARN, yet another resource negotiator. He is performing some activity. So MapReduce started, parallel processing started. Now reduce activity is going on, I think. That is why cursor stopped blinking. Okay, 100%, 0%. Now come on, go, 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 go. Yes, I think job has been done. So let me take you to, sorry for 1 second. I'm extremely sorry, actually my battery has been drained. So now the job is finished. I will show you. You must be having this line printed, completed successfully, something like this. Then your job is finished, and probably streaming worked in our favor, and outputs must be saved in the cluster. Now let me show you the outputs. So Hadoop fs cat output part. So we should be having, yeah, same, right, same results. So you can compare the results. So this is the constant. So our regression equation is something like, y is equal to 46.753 minus 0.275 times x. So this is what is the regression equation. Hopefully, if time permits, I will do one more video demonstration as how to go on with predictions, and then whereupon, because we may not be able to calculate coefficient of determination, and yeah, of course we have r square is, so coefficient of determination, f statistic, both of them need predicted values. So hopefully in my next video I'll demonstrate how to calculate the r square value and f statistic with the same data set. Thanks for watching this video. Stay tuned for the new content, and bye bye for now.